I build developer tools for a living. I live it and breathe it. I probably do it 12 to 15 hours a day most days. And I cannot keep up with all of the change. Like it is all that I dedicate my life to. And I cannot keep up with change.
Hello, folks, and welcome to Hangar DX. This is a podcast about developer experience and how engineering teams solve productivity challenges at scale. I'm your host, Ankit Chan, co-founder of Aviator. At Aviator, we build AI coding verification platform that creates guardrails for reducing AI slump. Today, my guest is Ryan. Ryan has spent a lot of time at Microsoft and Google. He's been behind a lot of new AI tools that we have seen around the world. I'm really excited for this conversation. Ryan, thank you so much for joining us. Can you please do a quick introduction?
Yeah, dude, absolutely. And first, thank you so much for having me on. I've listened to a lot of the podcast and really enjoy the conversations that you've had. Hey, everybody, my name is Ryan J. Salva. Today I work at Google, but I've got about 2.5 decades in the dev tools industry. I spent the last 2.5 decades working at startups, working at Microsoft, working at GitHub, working at Google, helping bring products to market like VS Code and TypeScript, but also a lot of GitHub code spaces, Copilot. And today now at Google working on AI dev tools, I probably spend a large part of my time working on Gemini CLI, Firebase, anti-gravity, kind of all in the soup there that is Google's AI dev tools portfolio.
Amazing. So there is a lot of things I would like to talk about. I'm sure this is going to be definitely focused towards the evolution of AI dev tools. Let's just start with your journey a little bit towards VS Code and getting into GitHub. How did you sort of see that evolution happening? How did GitHub's acquisition itself change some of that roadmap?
Yeah, absolutely. So I first came to Microsoft in, let's call it 9-ish, give or take a little bit, back when Microsoft was really kind of getting serious about the transition to mobile and Windows Phone. We all know exactly how that turned out. But it did produce kind of a renewed focus on web technologies and developer tools. At the time, I was actually working on a product called Expression Blend. That's vintage enough that we probably don't want to spend too much time talking about it, but there was a lot of cool, fun stuff that came out of that time. Fast forward to, what would that have been, 2017 or 18, I guess. And at that point, Microsoft started shopping around for kind of a way to expand their footprint, particularly in the open source and the non-C#, non.NET community. Microsoft obviously had a lot of strength around C#, having built that language and built that whole ecosystem. But they did not really have a lot of fans who were in the Java community or the Python community. It felt a little bit out of reach. GitHub ended up being a kind of a really good match. When you think about it, there's really two big reasons why Microsoft, from my perspective at least, invested in GitHub. There's the community, all of the wonderful people who are collaborating and building to there on GitHub. And then, frankly, there is all the data that comes with those people. You're very, very close to the open source ecosystem when you have GitHub. And that's not just about kind of the code that's there. It's really about hey, if you've got 90% of every deployed application that is open source and only the top 10% that is really your company's, your application's code, well, that open source code becomes very, very important. And so when you've got security vulnerabilities that get posted, you want to be able to get all of the patches, all of the new capabilities and features of those open source dependencies to production, to your deployed applications as quickly as possible. And so creating a better connection there became really important. That was, frankly, before AI and large language models was even part of the picture. The interesting thing, at least for me, very personally at that time, was I was leading two teams at Microsoft. Azure DevOps, which is kind of Microsoft's other DevOps platform, and what Microsoft calls one engineering system, or one ES. Think of it as the internal developer infrastructure for Microsoft. And so one of the things that we had to do is align the Azure DevOps team and the GitHub team during the kind of the acquisition, and kind of to bring those two roadmaps together. That was probably, frankly, from a people management perspective, let alone from an engineering perspective, one of the most challenging times of my career. You got folks who've poured their heart and souls into Azure DevOps for 1-2 decades at that point. And, to tell them, hey, now you've got to go and kind of work with and collaborate with and become a part of the team of a company that really felt like your former competitor. That's a big transition point where you've got to realign teams and realign the roadmaps together. But we'll fast forward a little bit, because you said you want to spend some time talking about kind of AI assisted developer tools. A little bit later, let's see, that would have been 2020, late 2020 or so. We actually had a funny moment there. GitHub started to experience one day. I was leading one of the infrastructure teams, among other things, at GitHub. And there was this massive surge in traffic onto GitHub servers, right? I mean, this is like huge spike in traffic. And we're like, oh my God, like what is happening? It's GitHub. It's a ripe target for bad actors of all kinds. We're like, what's going on? Who's trying to do a denial of service? Is there some kind of takedown? Is there something like that? We're like, what the? And so we started doing some kind of like research, and we're like, okay, doesn't look like it's, coming from any state actor that's known, no known IPs. We do a little bit more research, and it seems like it's coming from this particular cluster of IPs. And after a little bit of due diligence, we figure out this is OpenAI. What they're doing is they're going through and they're using our public APIs. I mean, basically just Git clone operations, and enumerating through and through all of the repos that were on GitHub. And so we eventually work our way to find some contacts in OpenAI, and we're like y'all, quit it, stop it. You're going to take down the world's open source repositories. And, they're very reasonable about hey, listen, we'll find a more reasonable, rational way to get you kind of, copies of some of these, this publicly available data in a way that is not going to jeopardize the stability and the reliability of the GitHub service. And so, it turns out that a year or two before that, over in Svalbard, Finland, I'm not sure if you're familiar with it, but over in Svalbard, it's like northern Finland, way up in the Arctic Circle, there is this Arctic seed vault, right? The seed vault, basically, it's seeds from apples and grains and grasses and all of the world's flora. The kind of theory here being that if the worst should happen, there's a meteor strike, there's a terrible nuclear holocaust, whatever it is, that there will at least be some location where you can reboot the world's ecosystem, the world's, the ecology, right? And so GitHub had said, well, what is open source if not the seed of knowledge for all of the world's software? At some point, if there's that terrible meteor shower, that terrible nuclear holocaust, not only going to have to reboot the flora and the fauna of the world, but you're also going to have to reboot the software. And so we had created basically a copy of all of GitHub at that time, put it on these silver gelatin special disks, and put that up in Svalbard, Finland. Well, that ended up becoming kind of the data set, as it were, or at least a part of the data set that we were able to deliver over to OpenAI for some of those initial training sets for earlier versions of GPT. Because of that collaboration, then we got in some investment from Microsoft at the time. We got early access to some of the GPT models and started tinkering around with them. And okay, what can we use this for? What's clearly there's got to be some kind of application here in software development. And it wasn't too long before we settled on, it was actually like within the first 2 weeks or so, that we settled on, hey, you know what? We already have autocomplete and just about every IDE at the time. It looks like we can really use this to create a supercharged autocomplete inside of the IDE. And so that was the initial kind of advent of GitHub Copilot. I think like 2020, 2021, somewhere right in there. Now, we ended up bringing GitHub Copilot to market as a technical preview within about a very short time, maybe 3 to 4 months after that. And it was really probably one of the most exciting times that I've experienced as a product manager bringing a product to market. Like, it's not often that you get 1.2 million or so developers signing up for a technical preview within a couple of weeks. Just really explosive growth. Like felt like freaking riding a rocket ship with the windows down. Just wild stuff. And that set us on the journey that I think we've all seen unfold over the course of the last, what is that now? Roughly 5 years or so. I think we've seen a lot of evolution in that time. The way that I've now kind of, with the benefit of not foresight, was it the benefit of retrospection, I guess? Hindsight, benefit of hindsight. That was the word I was looking for. Benefit of hindsight is, Ankit, are you familiar with the 5 stages of autonomous driving?
The levels, right? Yes.
Yeah, right, exactly, right. So like, stage 1 is basically like, if you drift over the line, your steering wheel vibrates, or you get a little chirp out of your, horn, right? You progress through the stages until you get to L5. L5 is like you're sitting in the back of the car playing checkers with your friend, and the car is just doing its thing, right? So I've kind of come to think of our journey in these last 5 years as a similar progressive stage of autonomous engineering, right? So those first days with GitHub Copilot, stage 1, slightly supercharged predictive text, right? Stage 2, we got to simple chat. I've got a little panel up in the side of my IDE. I ask a question about the code that's in front of me. I get a response back. Stage 3, I ask a question in natural language or submit a prompt in some way, and the system is able to reason or rationalize over the entire application in some way. It's able to essentially use a React loop to ask questions about the file system, about the relationship between components and the like. Right? Stage 4, we have these agents that are running, many of them often running in parallel, not just initiated by the human necessarily at the laptop or the keyboard. Some of them maybe even responding to SDLC events, but still with a fair amount of human oversight. We don't trust them quite enough yet to completely go off on their own and get us from point A to point B. Stage 5, we're all sitting in the back seat watching the agents kind of do their thing. We give them some general direction about where we want to end, and they figure out the problem from there. By my read, today, the vast majority of the industry is sitting somewhere between stage 3 and stage 4. Many of us are more comfortable using something like a Google anti-gravity, a Cursor, a Claude Code, a Gemini CLI. We're at the keyboard. We're giving the models instructions. We're letting them kind of iterate, but we're still in the driver's seat. Our hands are still firmly on the wheel. We're just working a little bit more collaboratively through natural language. The most sophisticated engineering teams, maybe the ones who don't even have to be sophisticated, the more courageous, the more foolhardy, the more risk tolerant, are using agents with a little bit more kind of event-driven operations, but often still with some kind of human review after the fact. We're all navigating the space between stage 3 and stage 4 right now. By the end of 2026, I think we're gonna, as an industry, gonna be planted pretty firmly in stage 4, at least in terms of the capabilities. The question is, are the people ready? Are the teams ready? Are the organizations ready? There's this William Gibson quote. You know William Gibson, science fiction
Mhm.
writer, right? Yeah.
Yeah, yeah.
Yeah, great guy. The future is already here. It's just unevenly distributed,
Mhm.
right? We are very much living that right now, right? And what I see uneven distribution really across two different dimensions, right? The first is skills, right? Like when I look at the most, again, courageous or foolhardy or sophisticated engineers, their ability to work with these agents and let them just write code for them, iterate, and kind of like deploy them all in parallel to go farm out my tasks. Those folks are just way ahead of what is probably 60 to 80% of the population, which is still doing predictive text, is still doing single shot, chatbot style development. And so we've got a real gap in kind of our overall adoption of these tools, these technologies, and these new engineering practices. And then second, it's really in how we're deploying AI across the SDLC. I mean, really, the last 5 years have been a journey of using AI for authoring code. Like code
Mhm.
now, it's wicked cheap. Like you can just, you can generate gobs and gobs and gobs and gobs of code. But when you look at the rest of the engineering lifecycle, the rest of where we spend our time designing infrastructure, troubleshooting and investigating live side incidents and performing retrospectives on those, cost optimization for kind of our deployments, building out and managing CI/CD pipelines. Like there's a huge other part of the practice of engineering that we've barely even touched. And so what we've really got is we've taken that predictive text that we had the initial idea for 5 years ago, and we really plumbed that through and through. But DevOps and SRE, man, like that is the next frontier of AI. And we've barely scratched the surface on that.
Interesting. Okay. I know you covered a lot of things that I wanted to cover, but there is a lot of also questions that have come up
Okay.
through these things. So let's start with kind of like, breaking down in a few things. I think I love sort of like your philosophy and thinking about like, what's coming up next. You did mention a big part of the shift is also the people side of things, which is
Yeah.
like, what roles do humans play? How do we actually, in a metaphoric way, like go to the back seat instead of holding the steering wheel,
Yeah.
right? So kind of like, what are you seeing? What are your sort of like ways in which you encourage and help kind of like, push forward some of this way of working?
Yeah. So there is the cultural change that one needs to drive, as you say, the people part of the change. And then there are the practices that you need to get folks to adopt. I want to maybe separate those out because those are slightly different things, right? In order to engender and to create the change within our teams, there are a few things that I do. Now I'm going to put on my like engineering leader hat for a second. So this is not Ryan, the individual contributor. This is Ryan, the manager of teams, right? For any of the listeners kind of on right now who are managing people and especially managing large teams, the first thing that I'd suggest is find either an individual or a small team that it's your A team. These are the folks who are your superstar engineers who know how to handle a little bit of chaos, right? Because they know their craft inside and out. Give them new tools, let them go practice and iterate and fail a little bit, but then succeed a lot in using whatever the new tool or the new practice is. Because your goal here is that you want to take a team that, or individuals who the rest of your team already respects, who are already known to have credibility within the organization. You want them to go prove out the new practice, and then you want to elevate and hold them up as a model And this is going to do a few things. One, if they're engineers that you already respect, then when they tell you this either does or does not work, or you need to do it in this way, you as an engineering leader will believe them. All of the rest of the team will believe them. They have that credibility. And if you're holding them up as an example of the right way of doing things, like let's face it, like we all emulate our heroes to some extent or other. And I'm not saying that these are the heroes of your team, but they're people that the organization presumably respects. And so everyone's looking to pattern their own career and their own trajectory off of the people they respect. And so first you have that exemplar team who goes out there and proves the case and shows other folks how it's done. Mm-hmm. Second, you build a kind of a group of vanguard, we'll call them champions, right? These are the folks who, once one team has proven out the practice, the tool set, just the mere concept of whatever tool it is you want to adopt, these champions are responsible for going out and taking those practices and holding office hours, leading hackathons, working with the team to kind of essentially train, enable, and be the champions of the change you want to create. Third here is that especially if you've got a large team, think certainly hundreds, if you've got hundreds of engineers, you want to be very methodical about the way that you roll out the change. You don't want to just say, hey, everyone, we're going to use these new tools now, get at it. That ain't going to work. That's just not going to work because people, they've got work to do, right? They've got deliverables, they've got milestones that they're working towards. It takes time to go and learn a new tool, to learn a new practice. And so ideally what you want to do is you want to take each unit, think of like an engineering director with 30 or so reports. You want to get them all in a workshop together, give them 2 to 4 hours to install the tools, to practice using them, to share tips and tricks, to have a moment of camaraderie where they can all get their first kind of introduction to
the aha moments. Yeah.
Right. Yeah. Then you want to measure adoption in your teams. You're not measuring anything about lines of code or PRs or productivity or anything like that. You're just measuring from team to team. I'm not saying from individual to individual. I'm talking from team to team, director to director. Hey, are they generally adopting the tools? Because you have to know, which is like, is the tool part of the equation? Or is it just being part of the overall engineering system in order to, are you successfully driving adoption? Once you've validated that you've got adoption generally within your organization, think about 70% or so of the team is using the tools. Now you can start to measure some of your engineering fundamentals. Is the number of defects per PR or per developer increasing? Is the number of security vulnerabilities per PR, or per developer increasing? Is your deployment frequency changing in any meaningful way? All of the normal engineering fundamentals that we all should be tracking for ourselves. I'm not saying we all do, but we all aspire to track for ourselves. Those are the kind of things to watch for. What you're looking for here is not so much, are we accelerating across the board in terms of I'm going to put this in scare quotes, productivity, right? I'm not looking for faster ship velocity necessarily. What you're mostly looking for is, are you regressing against any of your engineering fundamentals as your team is adopting a new tool or a new practice? And then over time, you can start to look for improvements to your engineering system in terms of whether that be on the dimension of quality, efficiency, throughput, any of those types of things. Last one that I'll say here on the people part of it is that, even if you're not driving change for hundreds of engineers, you're a smaller team, right? The hands down, the best thing that you can do, whether you're a small team or a large team, is just go out there and freaking talk to your developers. You hire your engineers, and most of us pay them handsomely because they're freaking good at what they do. They know They know their code, they know the application, they know their engineering systems. The best thing that we ever did at both Microsoft and Google is we have engineering surveys. The frequency varied based upon Microsoft versus GitHub versus Google, but it's still basically the same practice either way. Mm-hmm. You ask two questions, just two. How satisfied are you with your engineering systems and why? One is like a Likert scale type of thing. The other one is an open text box. Then, hopefully you're doing that semi-frequently. It's called monthly, roughly. Then you look at the people who are dissatisfied with their engineering systems. You then go do a kind of a cohort study, a grouping of the verbatims, right? And you look for groupings of words. Hey, it looks like the word flaky tests shows up frequently when someone is dissatisfied with their engineering system. Then you talk to maybe 5 or 10 or 12 of them, get a little bit extra color on top of what their verbatims were, and then go drive for the next 3 months improvement on whatever that particular issue or that particular pain point was. And you may use AI in order to solve the problem. You may not. Here, AI is just a tool to solve a problem. It is not the solution for everything in and of itself. Now, that's the people side of things. On the technology side of things, I think, and actually I was listening to one of your former episodes, and so Dave Farley was talking about the importance of context, of specification, specificity in how we write the code and how we validate that the code is doing what we thought it would be. And this is probably, the models are getting better and will continue to get better. The tools on top of the models will continue to get better, and they will start to become, optimized and improved a little bit more in tandem with each other, or like coupled together more than they are separately, right? For many of the last couple of years, a lot of tools have offered choice of models behind them. Reasonable, rational thing to do. I think what we're going to see is that the models start to get improved coupled with tools, because when you can optimize for tool calling or a particular kind of tool calling within the model, you tend to get better output. Having said that, though, context really becomes the most important thing that you can invest in. And what I typically look for is I look for this to be at the intersection of a few different planes. First, there is the context of being as a human, as like what's my personalized way that I like to work, right? Because we all have different color themes in our code editors. We all have different keyboard shortcuts that we've become married to, just as we'll have different ways of working that suit our personal style. Then we have the application that we're working in. This often gets expressed in like an agent's MD or something like that gets put into the repository today. Then you have your team context. Hey, this is not just how this application works, but this is how it connects in with the rest of the way our team's processes and workflows work. Then you have way up at the top level, the platform, the compliance and policy and governance and security practices that no matter which team you're in, everyone has to abide by. Then you have, for each individual task that you're performing, the task prompt, and getting folks to think about things in all of those different layers of how they marry those different levels of context, of specificity together is probably the biggest shift in the way that developer workflows really are starting to move towards. And that requires a radical change in the way that developers work, because you don't wander up to your keyboard and just start typing anymore. You have to, and typing code at the very least anymore, or putting an arbitrary question into a chat panel on the side. You really have to think about, how am I mirroring context from all of these places together? And just as importantly, I think one of the real challenges of the tools from the last couple of years has been that, well, when you just wander up to your keyboard and kind of iterate on ideas in a chat panel, at the end of the session, all of your intent, all of your instructions, dude, those just poof, they just evaporated, right? Now no one knows how or why you created things the way that you did because it was part of an ephemeral conversation. And so getting into a place where we're thinking about a durable artifact that persists past the coding session and is then part of the code review process, or even replicable, but can
Replicable.
be used
Mhm.
in future components that you
Referenced.
want to,
Mhm.
yeah, reference. Thank you. Can be referenced in future components. That is equally as important.
Very interesting. So I know we kind of like went on, and there's going to be a little bit more things I want to cover, but let's kind of like just double click a little bit more on this, right? Fast forward, let's say a year. I'm not even saying like 5 years because I feel like in 5 years things will be very different. But how? So one thing we are also hearing a lot is the roles are getting fused together, right? Like
Yeah.
so product managers, engineers, like now product managers can write code and engineers can understand the product
Yeah.
and the business side of things. How do you see sort of like, the responsibilities and the skills and the roles evolving, especially from software engineering perspective? Like you obviously work at Google, like which has thousands of engineers. How are you folks thinking about like upskilling or sort of like reskilling some of those engineers in terms of the roles and the responsibility and the skills?
I'll tell you where I think it's going. First, like you're dead on. You're spot on. Like the roles are fusing quite an awful lot. I guess the way that I tend to think about it is the roles are expanding more than they are fusing, right? So I was building out an application the other day, and I'm a reasonably good engineer. I'm a product manager who tools for engineers, and so I by nature code. I do not necessarily have training in data science or data engineering though myself. And I was, in this particular day, I was working inside of anti-gravity. I knew that I wanted to create I was creating a user reputation model and an image classifier,
Mhm.
and ended up using a combination of Gemini and I used Nano Banana to synthesize a bunch of basically a data set of images that would be used for the image classifier model. But like again, very little training, but I was able to go out and build these models effectively using AI to extend my existing skill set. I was a technical person to begin with, and I got
Mhm.
a little bit more expansive. I was able to move outside of my comfort zone. And so, what I see an awful lot of is that whether you're a product manager, expanding your skill set a little bit more to adjacent areas like engineering, or you're an engineer, expanding your skill set a little out to include data science or maybe
Mhm.
infrastructure design. If you're most developers, you know, we'll say don't spend most of their time designing infrastructure. It's more
Sure.
application development than it is infrastructure design. But like these models allow us to expand our comfort zone and to kind of include a wider variety of tasks in our day to day. I think over the next couple of years, we're going to start to see probably fewer job called specialization, like a consolidation in the number of job titles that we advertise for. And when we have a fewer job titles, that probably means that the jobs descriptions themselves will be more expansive in terms of the skills that we expect anyone to have.
Hmm.
In some ways, I mean, this even precedes my time, but like there was a time in which spreadsheets were the kind of thing that was the domain of technically trained, specialized folks. Now, like everyone works with spreadsheets. It's just part of any office worker's repertoire, right? Over time, I think, and this is actually the near future, we're going to see that software becomes a means of communication, iteration, not unlike the transition that spreadsheets went to the general office worker. That does not mean, I do not mean to imply here that domain expertise and specialization won't be valued. There is a lot of work that still requires a hell of a lot of specialization and domain expertise. But it does mean that some of the basic skill sets will be democratized a little bit. Now, at Google, I would say the kinds of things that we were doing, well, heck, I talked about having those champions before. Google has an AI champions program, right? We have folks whose responsibility is to go out and invest in educating and teaching and helping folks keep up with the pace of change that the technology is going through. Like, dude, I build developer tools for a living. I live it and breathe it. I probably do it 12 to 15 hours a day most days. And I cannot keep up with all of the change. Like, it is all that I dedicate my life to. And I cannot keep up with change. So we should not expect our engineering teams to be able to keep up with it, especially without investing in the training, the coaching, and bringing folks along. And so, we within Google are being very intentional about bringing in folks who do periodic workshops and like carve out time to say, you know what? I know we've all got deadlines, but just like we need to invest in our products to ship our products, if we want to improve our teams, we have to invest in our teams. And that means staffing the learning time, right? Investing in the learning time in order to improve our skills as craftspeople, right?
Yeah. Nice. Okay. So one last question. This is a hot topic recently. I wrote a post about how to kill code reviews. I'll share with you later.
Yeah.
But just the whole idea of, code reviews, where does that go? Because that's like one of the bigger aspects of, still human in the loop when we're doing development. Sometimes when I talk to some of my, architects and engineers, they're like, okay, sure, if we kind of remove code reviews and if things break, how do we kind of handle those situations? So just maybe your take on, where code reviews are going and kind of is it a world where we're seeing maybe code reviews becomes less relevant?
Okay, wow, this was an interesting question. All right, so is there a world on what time horizon where code reviews become yet less relevant? Sure. If you go far enough out, they will eventually, we don't all look at the compiled code after the compiler is done these days, right? There was a time at which you actually did have to inspect the compiled code to make sure that it all did right, 50 years ago. But so eventually we'll get there. Here's what I believe. One, there is a real danger with agent-driven code authoring that the PRs become too big for reasonable, rational merging. And so we all need to stay, just because the technology can doesn't mean it should. We should all stay grounded in good engineering practices and keeping the PRs small and atomic. And you can instruct agents to work that way. So I think that practice remains still relevant. Two, my team already uses agents to automate a lot of the work of code reviews. That doesn't mean that we've eliminated code reviews. It just means that we use agents to do the first and second pass of the code reviews in order to reduce the amount of time necessary for human senior engineer staff kind of level kind of inspection of the code, because there's always a lot of low-hanging fruit that an agent can just take care of, right? And plus the agents are great at doing things like deduping or triaging the PRs as well and getting them to the right people. So that's all super relevant and super effective. Ultimately, the path to eventually minimizing the necessity of code reviews is having good test-driven development and good high specificity in the natural language instructions that can then go and use automation to validate that the code performs as it should and has the right outcomes. And this is always, take AI out of it for a second. The goal of engineering has always been to automate as much as possible so that we have higher confidence that the code is performing as it should. And this is why testing becomes so very, very important. Right. And so that just naturally starts to decrease the amount of scrutiny that we need to give to code when we've got good tests that can validate it. Last here, I will say, is that one of the challenges that is still being, I think, how to put this, the industry is not yet quite fully realized or come to grips with, is that as we automate more and more of the code generation and the code authoring, that the intent of the agents at each step is going to become way more and more important. Like if we underspecify our intent at any point, the agents will then they will often be given the option to choose the best implementation path as they judge it to be. And so measuring the intent and the traceability of intent behind each of the steps is going to become equally important. And that amount of traceability, you're going to want to be able to perform in a code review, better understand the decisions that an agent made in order to measure whether or not it made good choices about the test that it was writing, as well as the code that it was writing. And that will still require human oversight in order to perform a judgment on the code and the decisions that were made.
Amazing. I kind of like generally don't do this, but I feel like, a lot of things that we're working on feels very aligned with stuff that you talked about. Like we have like stacked PRs tools to kind of like break down your changes into smaller one, actually like create referenceability with the audit trails, and also like creating multi-tier verification. Anyways, I'm not going to go into like a sales pitch here. I think we are over time already. So thank you, Ryan, so much for your time. And thank you, everyone who was listening. If you're interested in developer experience, work in DevOps, or in platform team, you can also join us in our virtual sessions at dx.community. We hold monthly off the record sessions to talk a lot about these type of topics. And also, yes, bring in people like Ryan to share some of the knowledge over the podcast. Again, thank you so much, Ryan. This has been a blast.
Dude, I had an amazing time. Thank you for letting me share a little bit. And listeners can find me online everywhere at Ryan J. Salva.
Awesome. Thank you.